Welcome. I recently had the opportunity to read a lot of TypeScript code and perhaps in the future refactor TypeScript code as well. My background is in Go, so I will explain my learning journey from a perspective of a Go coder. We first have to install TypeScript. Now I like Docker containers. I like my development environments in Docker containers. So I use this command to run up a Docker container running Node version 10 on Debian Stretch Slim. Then you need to create the equivalent of a Go mod file. It's called package.json with the command npm init. It will ask you a few questions and it will create a template package.json file for you. Next, we install TypeScript and a testing framework. Now, TypeScript doesn't come with a built-in testing framework, so you have many to choose from. I chose Jest, J-E-S-T, and Jest works with JavaScript, so you need another library called tsjest to compile on the fly to JavaScript. To check that your install worked properly, run the command npx tsc-v. Well, npx is run a binary from the npm package and tsc is the TypeScript compiler. So let's check what version of TypeScript I'm running. And I'm running TypeScript 4.1.3. We always start with a hello world. So this is how we define a constant in TypeScript. Hello world is a string constant and there is no printf, but there is console log from JavaScript. Well, TypeScript is a superset of JavaScript, so any JavaScript is also valid TypeScript. The refreshing thing I find about TypeScript is the lack or the absence of semicolons, because semicolons optional. It reminds me a lot of Go, implicit semicolons. I love it. I start off with my usual add two numbers function, but here I went a bit further and I created a module roughly equivalent to a Go package. So let's run it first. The first command takes some time to run. It's compiling all the TypeScript to JavaScript. Well, it's compiling hello TypeScript to JavaScript. And it's really taking some time. It's finally run. Once compiled, you get a JavaScript file, in this case hello.js, and I use the node command to run the JavaScript. And there you are, hello world, and 2 plus 3 is 5. So here is the arithmetic module. This is equivalent to a Go doc. It's inspired by Java doc, I guess. So it's a TypeScript doc, if you like. There is no uppercase convention for exported functions. So you use the export keyword. I like the export keyword because it's right next to the function you're exporting. So sum is an exported function. This reminds me of the Go syntax for declaring parameters and function returns, but it doesn't have the strong type system of Go. There is no int64 or float64. It's just numbers, strings, and objects, JavaScript types. This is actually an optional semicolon. You can leave it out, it doesn't work. It will work without the semicolon. So to test my sum method, my sum function, not method, we first need to install a testing framework, and that's the command again. After installing the testing framework, you need to configure it. In this case, I'm telling Jest that my tests are in subdirectories or directories named test, T-E-S-T-S, and they have an extension of TS or TSX. TSX is used for React Java, XML type extensions, but in this talk I will only use TS. And for those people who like to write spec type tests, describe so and so, it expects this, that and this, you can have the spec extension as well. And here this tells Jest to use the TS Jest, TS Jest, not TS Test, TS Jest extension to compile on the fly to JavaScript, the TypeScript to JavaScript. Here's how tests in JavaScript look like. Tests in TypeScript look like. You first import from my arithmetic package. You only need sum here, but for later I've also imported 3 nums and also a num. These are classes, but they are for later. I tried to write table-driven tests in the spirit of Go, and this is how you write a table-driven test in TypeScript. This is a for loop where each iteration of that is assigned to V. So let O, standing for output, be the sum of A and B, and we expect the output to be the same, to be equal as what we expect. Let's run the test. It takes some time because it's transpiling to JavaScript, and all the tests work. Now if you would just want to run a single test, you can use this incantation. And it will actually just look for the test name sum. And here we find that only that test name sum was tested, and it passed. And the rest of the test was skipped. Now I want to talk about TypeScript classes, roughly equivalent to Go types and interfaces. So looking again at our hello world function, we have a declaration, a definition of a new variable called tn. Variables are started using the keyword let. In JavaScript there is var, var, but in TypeScript let is encouraged for scoping reasons. You can read it up on your own. And just like in Go, we can alias arith to a shorter name. I've aliased it to AR. So that's how a new type is instantiated, or a new class in TypeScript is instantiated. And 2, 3, and 4 are assigned in the constructor to internal member variables, instance variables. And here I will print the sum of 2, 3, and 4 using the sum method of the tn instance. This is how the 3 nums class looks like. Our instance variables, the constructor. This is public because it's exported. So we should have a TypeScript doc to explain what this method does, and it does that, sum, and sub. Well, sub is not a good name, but I didn't want a long name for this demo. So basically it's A minus B minus C. Here is how a TypeScript interface is defined, strikingly similar to Go, except of course it is not type summer interface, it's interface summer in TypeScript. And here I've declared a function, an ordinary function, which takes a summer and returns a number. And it returns the summer's sum. Because 3nums over here has a sum method which takes no arguments, no parameters, and returns a number, it satisfies the interface. Right. So let's show how we use interfaces in action. Again, this is my hello world function. I've imported the arithmetic module and aliased it as AR. I've created a 3nums instance called tn sum. I've also created another object, instance of an object called AAS, standing for also a summer. Also a summer, as you will see, also satisfies sum. Why? Because this is also a summer. It has a sub. It doesn't care about the sub method. It does very much care about the sum method. The interface summer does very much care about the sum method. And it satisfies the summer because the method signature is the same. In this case, all it does is returns a fixed number 1. So let's test 3nums and also a summer. This is how we test object instances. We create a new object, expect the sum to be 9 because 2 plus 3 plus 4 is 9. Expect the sub 2 minus 3 minus 4 to be that value. And also test summer in roughly the same way. Now I'll invoke the test in a silent fashion or quiet fashion, and we'll see what it does. This is the noisy test. You actually show all the names. And this is the quiet test or the silent test. It takes some time to run, and all it says is it passed, no problem. It took 3 seconds to run the test, much slower than Go. Well, what can you do? It's transpiling to JavaScript. So let's run the demo code again in its entirety. So before we run it, it runs the library method. No, sorry, the library method was previously, but it runs a instance method. It passes a summer to my sum, and it prints both of them out. Thus, it compiles to JavaScript. Takes about 3 seconds. It's done, and it runs the JavaScript file. Node runs the JavaScript file. And there we have it. How do I feel about TypeScript and Node combination in comparison with Go? Well, to be honest, TypeScript feels less batteries included than Go. You need two main tools working with TypeScript: Node, which is the execution environment, and NPM or Node Package Manager, which is somewhat like the Go tool. TypeScript adds type checking on top of JavaScript, and it only has types like basic types like numbers, strings, and objects and arrays. So it's less strongly typed than Go's type system. Go's type system was designed ground up for the language. Also, TypeScript doesn't have a TypeScript standard library. It's actually JavaScript's library ecosystem, which is vast and quite good. But in comparison, Go has a well-defined standard library. TypeScript needs you to choose from many JavaScript testing frameworks. But because they are for JavaScript, you need additional tools like TSJS, not test here, needed to test TypeScript code. Go, on the other hand, has a TypeScript testing package already included, batteries included, in its standard library. As usual, if you want to download the code to this presentation, as well as to the code samples in TypeScript, here is my Git repository, my GitHub repository. I am Siu Yin and I work for Zendit.